All right, so today we're going to take a look at part 2 of dividing polynomials, and that's where we're going to focus on what we call synthetic division, which I can tell you is your friend compared to long division. It is a much simpler way to divide polynomial expressions. First things first, the divisor must be in the form of x minus r, meaning x cannot have a coefficient. You want to make sure each term is represented, even the zero terms, and we'll have some more examples of that. And then once again, make sure terms are written in descending order based on the exponents. So we're going to use that synthetic division to find each quotient. Now, first things first, we have to check, is our divisor in the form of x minus r? And here it is. X minus 4, that represents x minus r. What we're going to do now is set that equal to 0. And what we get is the number 4. We actually take that 4, and that's going to be the basis of most of our math that we're going to be doing. Now we're going to make sure we have each of our coefficients represented by our exponents. So we have an x cubed, an x squared, x, and a constant. So we go 3, 2, 1, 0. So each term is represented. I'm now going to take the coefficient of each term. So our first coefficient is a positive 2, and I'm going to take that positive 2 and write it down. Our next coefficient is negative 13. Our next coefficient is positive 26. And our last constant is negative 24. All right. I'm going to write down a series of steps on what you're going to do. First things first, you are going to drop the first coefficient. So we drop it. Boom. It's still just a 2. Second, you're going to multiply your r term by the first coefficient. And then place the product underneath the second coefficient. So here's my r. That's r. We're going to multiply 4 times 2, which is 8, and we're going to put the 8 right underneath. And now we're going to add, which is step 3. Negative 13 plus 8 is negative 5. All right, once again, we're going to start these steps over. Step 4, multiply the r by the sum that you just got. Once again, place the product underneath the next coefficient. All right, now it's 4 times negative 5, which gets us negative 20. We're going to add. So once again, add. 26 plus negative 20 gets us a positive 6. Step 6, repeat steps 4 through 5 until the end. All right, so once again, multiply our r by our sum, which gets us positive 24. We add, we get our sum of 0. This 0, or whatever number here, is our remainder. So in this case, we don't have a remainder. Our answer is quite simple. If we started off with a cube, we subtract 1, and it becomes a square. So our new coefficient is 2x squared minus 5x plus 6. So you just write each coefficient in descending order, starting with 1 less than the original dividend. So we had a cube first, and so we just take 1 away and it becomes a square, and these are our new coefficients. So these right here are very important because these are our new coefficients. New coefficients. All right, let's do this again. X plus 3 equals 0. So x is negative 3. So that means our r this time is negative 3. Let's make sure our coefficients are in descending order, our terms are in descending order. So x cubed, x squared, x, no variable. So they are in descending order. Now we write down our coefficients. 2, 3, negative 4, 15. So 2, 3, negative 4, 15. We drop our first coefficient, multiply by r. Negative 3 times 2 is negative 6. Then add. We get 3 plus negative 6 is negative 3. Once again, multiply by r. We get positive 9. Negative 4 plus 9 is 5. Multiply by r, we get negative 15. We get 0, which is our remainder. And our answer becomes what? Well, if we started with a cube, that means we're going to start with a squared. And here's my new coefficients. 2x squared minus 3x plus 5. We just go in descending order straight down the line because we have our new coefficients. All right. However, what happens when we're not in the form of x minus r? It gets a little hairier. So what we need to do is rewrite this problem. You're like, Gary, Miss Younger, let's rewrite some math. All right, so what we're going to do is we have 3x to the 4th minus 5x cubed plus x squared plus 7x divided by 3x plus 1. Now, I need this 3x to be just a single x, which means I have to multiply it by the reciprocal of my leading coefficient. So the reciprocal of 3 is 1/3. If I do it to the bottom, I must do it to the top as well. So what happens, 1/3 times 3 is 1x to the 4th minus 5/3 x cubed plus 1/3 x squared plus 7/3 x. Right now you're probably going, Miss Younger, this is absolutely gross. You know what, y'all? It is, but that's all right. 1/3 times 3x is x plus 1/3. We're still going to take the x plus 1/3, set it equal to 0. So our r is negative 1/3 now. Our leading coefficients are right up here. We have a 1, we have a negative 5/3, we have a positive 1/3, and we have a positive 7/3. We're going to follow these same steps. Oh, except we're forgetting one thing. We always have to make sure every term is represented and what we don't have a constant term. So we need to put plus 0 because every term must be represented. Even if it's a 0 term. That's a biggie. Don't forget that every term must be represented. So we have our 0. Drop our first term, 1. Negative 1/3 times 1 is negative 1/3. Add, we get negative 6/3, which is the same as negative 2. Whew, that's pretty nice. Now, negative 1/3 times negative 2 is positive 2/3. Once again, add 1/3 plus 2/3. Ooh, that's a nice solid 1. We're getting pretty lucky here. Negative 1/3 times 1 is negative 1/3. Once again, we're going to add, so 7/3 plus negative 1/3 is 6/3, which is 2. Hey, not looking so bad so far. 2 times negative 1/3 is negative 2/3. 0 plus negative 2/3 is negative 2/3. And remember, this is where we have that remainder. This is where we have that remainder. Now, when we write the answer, we're going to write it in a couple preliminary steps. So initially, we started with a term of 4. Oops. A term of 4, which means we're now going to have a term of cubed. So we have x cubed, 1x cubed, minus 2x squared plus x plus 2 minus 2/3 over x plus 1/3. However, x plus 1/3 was not our original divisor. So what we need to do is multiply both our numerator and our denominator by 3. So now, when I multiply negative 2/3 times 3, that gets me negative 2 over 3x plus 1. So our answer is actually x cubed minus 2x squared plus x plus 2 minus 2 over the quantity 3x plus 1. So yeah, many more steps than necessary, but we still got to learn them. All right, one more example just like that. We need to rewrite So we have 15b cubed plus 8b squared minus 21b plus 6, all divided by 5b minus 4. However, we know that this term right here has to be a leading coefficient of 1. So we need to multiply by its reciprocal. So the reciprocal of 5 is 1/5. If I do it to our denominator, we must do it to our numerator. So now this becomes 3b cubed plus 8/5 b squared minus 21/5 b plus 6/5 all over b minus 4/5. We're going to go ahead and take our b minus 4/5, set it equal to 0. We get b is 4/5. So now our r, when we do our synthetic division, is 4/5. We're going to write down all of our leading coefficients. In this case, the first one was 3. Our second coefficient was 8/5. So 8/5. Our third coefficient is negative 21/5. And then our constant is 6/5. Now we start the process. Drop our first, multiply 4/5 times 3 is 12/5. 8/5 plus 12/5 is 20/5, which is the same as 4. 4 times 4/5 is 16/5. So negative 21/5 plus 16/5 is negative 5/5, which is negative 1. So now negative 1 times 4/5 is negative 4/5. When we add it to 6/5, we get 2/5. Once again, this last term is our remainder. When we write our expression, we started out with a cube, so our answer becomes 3x squared plus 4x minus 1 plus 2/5 over b minus 4/5. However, we don't want a fraction in our denominator. So that means we're going to have to multiply by our denominator of 5. So multiply both our numerator and denominator by 5. What happens here is this becomes 2 over 5b minus 4, which was our original. So our answer becomes 3x squared plus 4x minus 1 plus 2 over 5b minus 4, where that 5b minus 4, or that 2 over 5b minus 4 is our remainder. All right. You will not have many problems like that on your assignment, but it's still good to know how to do it. If you have any questions, please send me an email.